What is the difference between compiled and interpreted languages? 1. Understanding programming languages, compiled versus interpreted. Programming languages can be broadly classified into two categories, compiled languages and interpreted languages. Each category has distinct characteristics that influence how code is executed, performance, and usability. Understanding these differences is essential for developers when choosing the appropriate language for their projects. 2. Defining compiled languages and their process. Compiled languages, such as C, C++, and Rust, require a compiler to translate the entire source code into machine code before execution. This machine code is platform-specific and can be executed directly by the computer's hardware. The compilation process consists of several stages, including lexical analysis, syntax analysis, semantic analysis, optimization, and code generation. Once compiled, the output is a binary executable file that can be run without the original source code. 3. Exploring interpreted languages and their execution. Interpreted languages, such as Python, Ruby, and JavaScript, are executed line by an interpreter at runtime. Instead of generating a separate executable file, the interpreter reads the source code, translates it into machine code, and executes it on the fly. This approach allows for greater flexibility and ease of debugging, as developers can modify their code and see the results immediately without the need for a separate compilation step. 4. Performance comparison, compiled versus interpreted. In general, compiled languages tend to offer better performance than interpreted languages. Since compiled code is translated into machine code ahead of time, it runs faster and more efficiently on the target hardware. In contrast, interpreted languages may exhibit slower performance due to the overhead of translating code during execution. However, advances in interpreter technology and just-in-time (JIT) compilation techniques have improved the performance of some interpreted languages significantly. 5. Development cycle, speed and ease of use. The development cycle for compiled languages typically involves writing the code, compiling it, and then running it. This process can be time-consuming, especially for larger projects, as developers need to recompile the entire codebase after making changes. On the other hand, interpreted languages allow for a more iterative development process, enabling developers to test small code segments quickly and make adjustments on the fly. This can enhance productivity and make debugging easier. 6. Cross-platform compatibility and portability. Compiled languages can face challenges in terms of cross-platform compatibility. The machine code generated by a compiler is often specific to a particular operating system or hardware architecture, which can necessitate recompilation for different platforms. Conversely, interpreted languages are generally more portable, as the same source code can be executed on any platform with a compatible interpreter, making it easier to develop cross-platform applications. 7. Use cases, when to choose each language type. The choice between compiled and interpreted languages often depends on the specific use case. Compiled languages are typically favored for system-level programming, performance-critical applications, and software development requiring fine control over hardware resources. Interpreted languages are often chosen for rapid application development, scripting, and web development, where ease of use and flexibility are paramount. 8. Hybrid approaches, the best of both worlds. Some modern programming languages incorporate both compilation and interpretation techniques to leverage the advantages of each approach. For example, languages like Java and C# are compiled into an intermediate bytecode that runs on a virtual machine, JVM or CLR. This allows for platform independence while maintaining performance optimizations through JIT compilation. 9. Conclusion. Choosing the right language for your needs. In conclusion, the difference between compiled and interpreted languages is significant, influencing performance, development speed, and use cases. Understanding these differences helps developers make informed decisions when selecting programming languages for their projects. Ultimately, the right choice will depend on the specific requirements of the application and the developer's goals.